we are discussing. For this reason, we commonly break networks into backbones and segments. Understanding the backbone. A backbone is a part of the network to which all segments and servers connect. A backbone provides the structure for a network and is considered the main part of any network. It is usually a high-speed communications. So here you can see you've several networks here, 4 switches, and here's the backbone connection then for this network. Technology of some kind, such as fiber distributed data interface or 100 megabit Ethernet, fast Ethernet, all servers and all network segments typically connect directly to the backbone so that any segment is only one segment away from the server on that backbone. Because all segments are close to the servers, the network is more efficient. Understanding segments. Segment is a general term for any short section of the network that is not part of the backbone. Just as servers connect to the backbone, workstations connect to segments. Segments are connected to the backbone to allow the workstations on them to access the rest of the network. Selecting the right topology. Each topology has its advantages and drawbacks. The process of selecting a topology can be much like buying a pair of shoes. It's a matter of finding something that fits, feels right, and within your budget. Instead of asking what is your shoe size, ask questions such as how much fault tolerance is necessary and how often will I need to reconfigure the network. Creating a simple network for a handful of computers in a single room and is usually done most efficiently by using a bus topology because it is simple and is easy to install. Larger environments are usually wired in a star because moves, adds, and changes to the network are performed more efficiently with a physical star than any other topologies. If you need uptime to the definition of fault tolerance, that is 99% uptime or less than 8 hours of total downtime per year, you should seriously consider a partial mesh network. While you are thinking about how fault tolerant a mesh network is, let the word maintenance enter your thoughts. Remember that you will have n-2/1 connections to maintain, which will quickly become a nightmare and could exceed your maintenance budget. Generally speaking, you should balance the following considerations when choosing a physical topology for your network: cost of installation, ease of maintenance, and cable fault tolerance. Physical media. Although it is possible to use several forms of wireless networking such as radio and infrared, most networks communicate via some sort of cable. In this section, we look at 3 types of cable: coaxial, twisted pair, and fiber optic. Coaxial cable, or coax, contains a center conductor made of copper surrounded by a plastic jacket with a braided shield over the jacket. A plastic such as PVC or Teflon covers this metal shield. Teflon type covering is frequently referred to as a plenum rated coating. That simply means that the coating does not produce toxic gas when burned as PVC does and is rated for use in air plenums to carry breathable air. This type of cable is more expensive but may be maintained by electrical code whenever cable is hidden in walls or ceilings. Plenum ratings applies to all types of cable. Coaxial cable is available in different specifications that are rated according to the type system. Different cables have different specifications and therefore different RG rating designations according to US military specification MILC 17. Distance and cost are also considerations when selecting coax cable. The thicker the copper, further the signal can travel, and with that comes higher costs and less flexible cable. Using thick net cable. The original Ethernet cable is known as thicknet cable or thicknet. It is also called 10 base 5 and it's graded as RG8. To the folks who install the cable, it is more commonly called a frozen garden hose because of its half diameter. With thick Ethernet, a station attaches to the main cable via a vampire tap which clamps onto the cable. Vampire tap is also named because a metal tooth sinks into the cable, thus making the connection with the inner conductor. The tap is also connected to an external transceiver that in turn has a 15-pin AUI connector, also called DIX or DB15 connector, to which you attach a cable that connects to the station. DIX got its name from the companies that worked on this format: Digital, Intel, and Xerox. So here is a picture of a 10 base 5 network. Now, not every thick Ethernet cable connection type is a DIX. The other option that is found occasionally is the N series connector. The N comes in a male female screw and barrel configuration. A CB radio uses PL259 connector and the N connector looks similar. Thin Ethernet. Thin Ethernet is also referred to as thin net or 10 base 2 is a thin net coaxial cable. It is basically the same as thick coaxial cable except that the diameter of the cable is smaller, about half in half 4-inch diameter. Thin Ethernet coaxial cable is RG58. With thin net cable, you use BNC connectors to attach stations to the network. It is beyond my province to settle the long-standing argument over the meaning of the abbreviation BNC. BNC could mean bayonet connector, bayonet nut connector, or British naval connector. What is relevant is that BNC connectors lock securely with a quarter twist motion. So here is a picture of a 10 base 2 network configuration. So I'm going to leave it today. I'm going to leave it here today for this video. So if you like listening, please consider like, sharing, and subscribing. Thank you.